Look at this question. Remember I told you we are on function of function. So I'm going to solve as many questions as possible on this topic to enable you have a balanced perspective of this topic. I want you to come to balance when it has to do with function of function. I want to have an in-depth knowledge of this. So I'm going to solve many questions, both simple and difficult questions on this, so that anywhere you see the question, you can solve it. Or maybe you see something similar to it, you can solve. Or something, maybe whichever. Let's get started. It says if f of s contains x squared plus 2 and g of s contains 2x plus 2, find f inverse g of 2. Now, solution. What do you do? First of all, let's agree that f of s is equals to x squared plus 2 and g of x is equals to 2x plus 2. Now, we are looking for f inverse of g of 2, right? So, but we need to find f inverse of x before working on this particular question. You do understand now? So let me find this first. Let y equal to x squared plus 2. So this is y minus 2 equals to x squared, right? Good. This x squared equals to y minus 2. When you square both sides to make s, subject to a formula, square both sides to make s, subject of formula, we're going to have x is equals to root y minus 2. Root y minus 2. When you have that, we can boldly say that f inverse of x is equals to root y minus 2. Now, let's find f inverse g2. Let's find f inverse g2. Now, don't forget that I told you something about changing y to x. So here now, we call it what? X, x, x. You do get? Now, to find f inverse g2, what do we do? Over here, we know that our g is 2x plus 2. Okay, let me not confuse you. G of 2 is equals to 2x plus 2, according to what we have in the question. This is 2. Did you get that? Now, I think we need to first of all find f inverse g, gs, or we can still go directly by anywhere we see x, we're going to substitute with this. So let's first of all look for f inverse gx, which will give us root in bracket 2x plus 2 minus 2. Root in bracket 2x plus 2. This 2x plus 2 is representing this x here. Do you get that? Now, if we are to continue from there, this means 2x plus 2 minus 2. And this means root 2x, because plus 2 minus 2 will give us what? 0. So now to find the main question, which is f inverse g2, we're going to use this root 2x. Root 2x. So this root 2s, anywhere you see 2s, you replace it with 2, and this becomes root 4, and the answer is what? 2. We have that in the option, yes, and the answer is what? B. Let me quickly run a recap on this in case you don't understand. I said f of s contains x squared plus 2 according to the question. G of s contains 2s plus 2 according to the question. But we are asked to find f inverse of g2. But there's no way you're going to find f inverse of g2 if you don't first of all find f inverse of gs. So here, you know now, normal inverse of a function, I told you that you let y equal to the function itself, then make s subject of formula. So you will recall when I cleaned the y here to remind you that s ought to be there, because after making s subject of formula, you then change the y to x according to the principle. We got this as f inverse of x, but g of 2 contain 2s plus 2. So before we could find f minus g, f inverse g2, first of all, you're going to find f inverse gx. That was what we did here, and we got root 2x. So to find f inverse g of 2, we're going to have root 2x, and anywhere you substitute, anywhere you see x, you impute 2 there. We got root 4, and that is 2. Thanks for watching.